topic of this video is corrections, and specifically welds, weld filters, and miters. On the Welds tab, you can decide how you want to correct your welds, whether you want to move them or cut them. This refers to any weld symbols that may be in the safety distance, near a flange or something like that. This will move them so that they can be scribed, or it will cut them. If it's in the safety distance or part of it's in the safety distance, it will cut off anything that's in that area. I would think that if you want to scribe your welds, you would probably want to move them so you get the entire weld scribed. Here you can decide what the minimum text height for those weld symbols will be. In this case, I've set that at 3/8 of an inch. On the Weld Filters tab, you'll notice that we have different profile tabs again. They are all identical. Once you know how to set one up, you'll know how to set up the rest. Just make sure that you've got them all set up the way you need them to be. First thing is weld style. You can either do full lines, pop marks, or corner lines. I'm going to have it set for full lines. And that way it's going to scribe the entire weld symbol. Otherwise, I'm just going to get pop marks where those weld symbols are, or I can get corner lines, and then it's only going to give me bits of the weld symbol. So I'm going to leave it for full lines. Safety distance from edge, we can pull those scribes back from the edge so that we don't scribe something out on the edge once again and maybe potentially damage the tool. And safety distance from flange, this is also just for the petty writer. So we would have flange height from web. This is essentially the length of the petty writer torch. The safety distance below flange height, this is half the diameter of the torch plus a little bit extra so that we have some clearance to the inside of the flange. And then safety distance above flange height, this is above the half the width of the mechanism above the torch, so that we make sure that that mechanism is not running into the flange as well. Generally, this is around 8 inches. This is around 7/8 or 1 inch, and this is around 2 3/4. Those are general values that we might see there. All of these values can be measured directly on the torch physically, or on the machine physically. Any weld symbols that might be outside the material, we can choose to clip them off or cut them off if we choose to, just by simply checking that box. The next tab we have is the miters tab. Here you're going to enter the values for your saw. Whatever saw you're going to be cutting this with, you put in here what the capabilities of the saw might be. If you're using one of our larger 1100 or 1250 DG saws, those values would be -60 to a +60, and you would need to do that on both lead edge and trail edge, or left edge and right edge, as it's stated here. Once you have something that's outside of that range, it will automatically convert it to whatever we have chosen here. Now, those machines are not capable of doing a Y miter. A Y miter is a flange miter. So they're not capable of doing that, so we simply leave that at 0. And then we just set the parameters of the cutting across the web, or the Z miter. So from a -60 to a +60 on both ends, in both directions, obviously. So once it's outside of that range, or outside the range of any of this, I can choose to either do nothing with it, remove it, put pop marks where that cut is, scribe it, or cope it. If you happen to have a coper, this is a really easy way to create a compound miter. If you have something that has a flange cut and a web cut that are both at a miter, you can program those just as a miter cut, and this would automatically turn it into a cope. If you don't have a mitering saw, you could set those parameters up here all for 0, and then anytime it has a miter, it will automatically turn it into something else. Well, maybe you're going to turn that into a scribe and then scribe it or cut it by hand later on with your fitter, or someone else. So gives you many choices to be able to turn this into other features that can then be done in a secondary process. Whatever you choose, if you choose cope or scribe as you saw there, we have to have a kerf value. That's the amount of material that's going to be removed in the cut. So we have to make sure we put a value in there so that Raptor adds that extra material there for you, so your part doesn't end up too short. If you're going to run this on a coper, you need to tell it where you're going to split the web cut. The web is either going to start in the center and go one way and then come back and go the other way, or it can also start at the flange, inside the flange on one side, and cut to inside the flange on the other side. So you get to tell it at what percentage of that web you want to actually cut, or where you want that cut to start at. I typically just leave it at 0 so that I'm starting just inside the flange and going to the other flange. Anytime you have a double Z miter, this would be a miter that goes in two different directions on the web. You can tell it to either do nothing, remove it, pop mark it, or scribe it. And you could also tell it to do underside marks if you want to. But you need to have an underside scriber to be able to take care of that. So here you're going to tell it how to handle those. A typical double Z miter would be the bottom of a stair stringer, the floor level bottom of a stair stringer. So that's a typical instance or example of what a double Z miter would be. I typically would set it for scribe there. Here I'm either going to set it for cope because I'm going to a coper, or I'm going to set it for scribe because I'm going to have somebody cut this by hand later on. So those are my two normal choices, and that's all for this video. Thank you.